Alright, this is the review for the retest unit 2, and this is part 2. If you didn't watch part 1 yet, go back and watch it. Then come back and watch this second, because this is specific examples just like you're going to see on the retest. I'm going to go through this pretty quick. What you should do is write each one of these down along with the video. You'll probably have to pause and rewind in order to write them down, but when you write things down, you'll remember them much more. I want you to turn this in to me when you got this written in order to do your retest. So I want you to write all this down and turn it into me showing me you did this before you do your retest. All right, here we go. So if we have this sentence, obtuse angles have measures more than... I want to write it as an if-then sentence. So I'm going to start if an angle is obtuse, then it has a measure more than 90. Then the hypothesis is just this first part right here. I'm going to highlight it. This is the hypothesis. It comes right after the if. So I'd write that part right there on this line. The conclusion comes after the then. It's this part right here. I'm going to highlight it a different color. And I'm going to put that, I would take and write that right here on this line. Okay, that's it for the first question. Your first question on your retest is going to look just like that. Write an if-then statement, write the hypothesis, write the conclusion. All right, here's your next one. Write this as a conditional statement. A quadrilateral has 4 sides. When you make that if-then. If it is a quadrilateral, then it has 4 sides. So what's the hypothesis? The hypothesis is this first part that's after the if. That's the hypothesis. It is a quadrilateral. Then this part, it has 4 sides. The part after the then, that's the conclusion. So I'd take and write that part right here. Okay, so what I'm going to do is I'm going to go through here, and this is the second kind of questions you're going to see. You'll notice they ask us to find the converse, the inverse, and the contrapositive. And I'm going to do that first instead of just doing it in order. I'm going to do this first. The converse is where I switch the order. So I'm going to write the second part first. So here's my conclusion. I'm going to highlight this like we have been so we can see it. So when I switch the order, it's going to be the second part first. If it ends in 3, then a number is odd. I literally just switched the order here. Now I'm going to write the inverse. I take the original one and I just make the original one not. If a number is not odd, then it does not end in 3. You don't need to write these in caps. I'm just doing it so you see that they're there. It's exactly the order of the original. It's just got the nots in it. And finally, contrapositive, I reverse the order and I make it negative. You can think about taking the inverse and just switching it. So let's start with this. If it does not end in 3, then a number is not odd. So once I've done my converse, inverse, and contrapositive, I'm going to come back and do these other 2 questions. So this question says, determine if the converse is true or false. Each one of these has a place where it asks us that. So let's look at the converse. Here's the converse we're going to decide on. Here's the converse. Is this true or false? If it ends in 3, then the number is odd. Well, that's true. If it ends in 3, 0, 3, 13, 23, it's odd. Then it also asks me a question, can this be true? Can this be written as a true biconditional? Well, we said that the converse was true, but the original also has to be true for it to be, for the biconditional to be true. Is the original true? If a number is odd, then it ends in 3. That's false because it could end in 5 and still be odd. If these are not both true, these both have to be true for the biconditional to be true. If one is false, then this is not a biconditional, and you'd circle no. Okay, I've got just a couple more examples. Be sure that you are writing these down because I want to see that you did these before you turn in your work. So again, I'm going to do the converse, inverse, and contrapositive first. Remember the converse, I just switched the order. So first I'm going to highlight this so we can see the two parts. This is the conclusion. This is the hypothesis. So for the converse, I'm reversing them. If it is a square, then a figure has 4 right angles. Just reversed it. Just took these, reversed them. Now I'm going to do the inverse. Remember, that takes the original order and it just puts knots in. So if a figure does not have 4 right angles, then it is not a square. If a figure does not have 4 right angles, then it is not a square. You don't have to put them in caps. I'm just doing it so it kind of points out that's what we did there. And then the contrapositive, it switches it and makes it negative. You can always think about it as just taking the inverse and switching the order of the inverse. Let's just look at this one, and I'm just going to make that one gray. So I'm just going to take this one and I'm just going to swap the order of this one to make the contrapositive. So if it is not a square, then a figure does not have 4 right angles. So I did those 3 parts. Now I want to go back and answer each question. Can this be written as a true biconditional? Well, both of these have to be true for this to be a biconditional. Let's look. Is this true or false? If a figure has 4 right angles, then it is a square. Well, that's false. It could be a rectangle. So as soon as I see a false, this is a no. You're going to circle no on your retest. All right, so then we have determined if the inverse is true. So you look at the inverse and you say, if a figure does not have 4 right angles, then it is not a square. Well, that's true. If it doesn't have 4 right angles, it can't be a square, so that's true. You're going to circle it again on your test. So this is the last one of this kind. Here's our original statement. So first I'm going to write the converse, inverse, and contrapositive just like we have. Converse, I just switched the order. If 2 angles have a sum that's 90 degrees, then they are complementary. Here I had to switch the words around just a little bit to make it work, but notice here's the sum is 90 degrees. That went here. Sum is 90 degrees. And here, our complementary is on this side, and that had to come over here, our complementary. I'm not really counting off if you mess up the English part. I'm mostly concerned with you understand that converse is the one that switches the order. The inverse is the one where you take the original and you just put in knots. Look, I can even just take the original, because I don't have to write it. I can just take the original, and I can just go in here and put knots. If 2 angles are not complementary, then their sum is not 90 degrees. That's literally all you do with an inverse. You take the original one and you make them both not. For contrapositive, I can just take the converse, which is switched, and I can put in knots. If 2 angles do not have a sum of 90 degrees, then they are not complementary. That's all the contrapositive is. I take the one that was switched and I put in the knots. That's it. All right, now let's go and answer the extra questions. Can this be written as a true biconditional? Well, let's look at the original. If 2 angles are complementary, then their sum is 90. True. That is what complementary means. And if 2 angles have a sum of 90, then they are complementary. True. That is what complementary means. So this is a yes. If both of these are true, then that's a yes. You circle yes on your test. And then it asks, determine if the contrapositive is also true. Well, if 2 angles do not have a sum of 90, then they are not complementary. That's true. The last part of the test was the difference between undefined terms, theorems, and definitions. Undefined terms, those are our simplest terms in geometry. That's a point, line, and plane. That's what it is. Be sure that you copy this part down on your notes so that you remember it. Point, line, and plane, that's our undefined terms. Pause and rewind the video if you need to. Theorems are statements that have been proven. In order for it to be a theorem, it has to be something that we have proven and that we can prove. On the other hand, definitions are statements that do not have to be proven. I don't have to prove to you what the word complementary means. We just accept that the word complementary means that the angles add up to 90. Everyone in math has agreed that that's what that word means. It's just like we don't have to prove to you that this color right here is yellow. That's just what we all understand it to be. That's a definition. Okay, you should have copied all this down. Pause, rewind, go back, watch this video again. Make sure you copied all these examples down because you remember things better when you write them down. I want to see that you've done all of this before you start your retest. If you do all of this, you're going to do fine on the retest because the retest looks just like this part that I just did.